All right, hi guys. Welcome to 3.4 notes. Our notes today, we're going to be talking about exponential equations. You have 3 review questions. Go ahead and do those. I will pause and then I'll come back and we'll talk about them. I'll give you a couple of seconds. Go ahead and pause. All right, here are the answers. The first one, the range, it's everything from 4 to infinity. An exponential is basically looks something like this. It's a growth function. It's got to go up 4, so it's telling you it's everything above 4. For the second one, 19 log of 0.0001 minus 19 log of 1. That really means 9 log base 10 of 1 over 10 to the 4th minus 19 log base 10 of 1. And then doing each one of those pieces, you have basically the first one says log base 10 of 10 to the negative 4. Those just cancel each other out and you get a negative 4. And then the second one, you have a log base 10 of 1. Well, that's going to be 0. So you end up with the other part of this, so your answer is negative 36. And then for the last one, the range of a natural log function. Since it's a log function, it has a range of infinity to, or negative infinity to infinity. So today we're going to talk about solving exponential equations. In order to solve an exponential equation, you must do one of two things. Either you try to get the same base on each side so you can cancel out the bases, or if you cannot get the same base, then use the inverse of an exponential function, which is a log. Or you could use ln. And you're going to use ln when you're dealing with e because ln of e is equal to 1, which allows us to eliminate it. So note, always isolate the base and the power first. Solve each exponential by getting the same base for each. Looking at this one, it's 2 to the 2x minus 1 is equal to 8 to the x plus 3. Trying to get the same base, you're going to get 2 to the 2x minus 1 is equal to 2 to the third power times x plus 3. Now, the reason this works, pretty straightforward. If you're saying you have the same bases, then if the two bases are equal, then the exponents that go with them must also equal each other. That's the goal. Eliminate the bases, and now we do the work. 2x minus 1 is equal to 3x plus 9. Then we're going to solve this out. This is going to be moving the 2x to the left. We're going to get x on this side. Subtracting 9, we get negative 10. So it's saying that x is equal to, x is equal to negative 10. What should we do here? Well, you should plug these back in and make sure that they both make sense here. That would be the case. You can do that by just simply plugging them back into the original equations. This is going to say negative 20 minus 1, so that's going to be negative 21. So it's 2 to the negative 21st is supposed to equal 8. This one, plugging that one back into the original, you're going to get negative 7. So doing that math, you should be able to see that this is going to work out. Let's look at the next one. 9 to the x is equal to 27. Well, both 9 and 27 have 3's in them. So when you're looking at one like this, that's how you kind of want to start. 3 squared is going to give you 9, and 3 cubed is going to give you 3 as far as an exponent is concerned. So this is going to say 2x is equal to 3. So x should equal 3 over 2. And then plug it back in to make sure that it works. If I take 9 and I say I'm raising it to the 3/2 power, well, that means the square root of 9, and I'm going to cube that. That will work. So that is the answer. Let's look at the next one. 4 to the x is equal to 1 over the square root of 2. So we need to be able to get these to the same base number. Looking at this, I might want to rewrite this. I'm going to go for 2's here. So this one's going to say 2 squared, because that's 4. This one, hopefully you would see that is really 1 over 2 to the 1/2. And then I would want to rewrite this by moving it to the top of the fraction, which means this becomes negative. Now I have the same bases. Now I can say 2x is equal to negative 1/2, which then would lead me to say that x is equal to, and in this case, dividing by 2 or multiplying by 1/2, you get negative 1/4. So plugging that back in should give you the same answer here, which would be the case. Now, this one might be a little harder to plug back in, but you could use your calculator and just plug it in and check it. But you'll see that it is correct. The next one. This one is an 8 and a 16 as bases. Very tempting to say 8 to some power, but 8 to some power won't give you 16. You could do this a couple different ways. But the main way is that they both have 2 as a base. So that would be the way I would approach this. This is 2 cubed. This is going to say 3 times x plus 1. This is going to say 2 to the 4th. That's x minus 5. Then we need to do the work to solve this out. It's going to be 9x plus 3 is equal to 4x minus 20. I'm going to get a 5x over here when I subtract 4x to the left. I'm going to get a negative 23 right here. That makes this x is equal to negative 23 over 5. Sometimes they work out nice and ugly like this, but hey, that's all part of it. Plug it back into the original function and check. You will see it's correct. The next one. Sorry, got to get this thing bigger again. The next one we have e to the 2x plus 1 over 1, or is equal to 1 over e. Well, e is obviously the common base here. So we're going to say e to the negative 1. Now the bases are the same, so we say 2x plus 1 is equal to negative 1. Subtract, we get negative 2, and then x would equal negative 1. Plugging it back in, making sure that it works. If you put negative 1 in here, you get negative 2. Negative 2 plus 1 is negative 1. E to the negative 1 is 1 over e. That works. And the reason that you do want to plug these back in, sometimes you may run into one that doesn't work. It's an erroneous solution, so you need to make sure that you are checking. Here's the next one. Obviously, 5s look like the right thing to do here, so 5 to the 2x minus 1 is equal to 5 squared times x plus 1. 5s are the same at the base, so 2x minus 1 is equal to 2x plus 2. When I subtract, I'm going to get negative 1 is equal to 2. This is not correct, so it tells us there is no solution. And this is why you definitely want to make sure you're checking, because sometimes there will be no solutions. So this is a situation where we have just the same base. We're able to get to the same base. But now I'm looking at this next one. It says solve each exponential equation, round to 4 decimal places. Think about change of base as well. I'm looking at this first one. It's got a base of 5 and a base of 17. They have nothing in common, so there's no way to really do that in this method. So the only way that we can really do this would be to rewrite this as a log function. When you say rewrite as a log function, everybody's going to have a different way of explaining this, so it's really just up to you and what you're comfortable with. For me, I know if it's an exponential, then it has to go to a log. It's going to have the same base. And then its left to right is equal to the middle. So this one, they want us to solve, and they want us to use change of base. So this is going to say x is equal to log of 17 over the log of 5. Remember, we did this before, and you can use natural log just as easily. They said they want us to come up with an answer that's rounded to 4 decimal places. So we will do that. We're going to say log 17, close your parenthesis, divided by log of 5. Going to get an answer that says 1.7604. That is rounded to 4 decimal places. Let's look at the next one. So we have 11 to the 2x is equal to 19. Obviously, we can't get to the same type of base given those two numbers. So we're going to do the same thing. We start with a log because this is an exponential. The base has to stay the same. Its left to right is equal to the middle. Now, obviously, this one has an extra step you have to take. So we have to divide out the 2. I'm just going to write it as 1/2 and then say log of 11 to the 19. That means then I'm going to be saying 1/2, and then I'm going to say, and we can use either one. I'll use natural log in this particular one, natural log of 19 over the natural log of 11. And then we get an approximate answer. So looking at this one, I would be doing the same thing. 1/2 is really just 0.5, so I would say 0.5. And then I would just go through the rest of it. I might open a parenthesis here and say natural log of 19 divided by the natural log of 11. And then when you do the work, you're going to get an answer that says 61396. But remember, we're rounding this one off. This one's going to say 0.6140 because you have to round. Sorry, we're kind of going into the other problem here, so just make some room. This is e to the x plus 1 is equal to 7. So obviously we need a natural log here. Log base e, correct? So this is the natural log of, if I had the e here, then it would be 7. And that's going to equal x plus 1. So x is going to equal, this is the natural log of 7, and then minus 1 on the end. Plug that in your calculator to get an answer for this one. It's going to say the natural log of 7 minus 1. You're going to get an answer of 0.9459. So 0.9459. That would be our answer. Hopefully everybody's kind of seeing how this works. The next one, I got a little bit carried away there, so let me fix that real quick. It says 2x there. So first thing we have to do, we got to get the exponential by itself. So e to the 2x is equal to 2 because you're dividing 7 over the other side. Now it's ready to go. This is ln of 2 is equal to 2x. So x is going to equal, I have to divide the 2, so that's 1/2. And then from there, we're going to say natural log of 2, which will be approximately, going back to my calculator, 0.5 times the natural log of 2. And we should get an answer that says 0.3466. Hopefully everybody's kind of picking up on this. It's not terribly hard. Just got to do pieces together here. Okay, we got to get the e by itself. So first step, e to the 3x is equal to, subtract 1, you get 7. Then rewrite. It is the natural log of 7 is equal to 3x. Now I'm going to divide. So this is going to say 1/3 ln of 7. Which is approximately. Now, the other ones were halves. They're easy to deal with in terms of the number. This one's going to be a little different. So we have to say 1 divided by 3. You can't say 0.33 because it's not going to give you the answer you're looking for. Open a parenthesis. Natural log of 7. Close 2 parentheses. Hit enter. You're going to get 0.68 or 6486. So 0.6486. Hopefully everybody's okay there. We're just solving by writing them as a natural log and then plugging the natural log into our calculator and using change of base. And it's important that you use that right now. I know your calculators might have a log base function where you can just plug things in. But come test time, you're going to have to show us, how to do this. So I'm just warning you now, you better get some practice at it. All right, for this next section, we're looking at solving these same things here. So we're going to take one each kind of at its own pace, and we'll just go through them. Okay, so this one, the exponential is by itself, so I don't need to do anything there. I just need to rewrite it. This is going to be, I'll say log base 3 of 11.3 is equal to x over 5. Multiply both sides by 5, so this is going to say x is equal to 5. And I'm going to rewrite this thing, natural log of 1.3 over the natural log of 3, so that I can get an answer. Plug this into my calculator. It's going to say 5 parenthesis. Then it's going to say natural log of 11.3, close my parenthesis, divided by natural log of 3, close both parentheses. We get an answer that says 11. So this is going to be 11.0358. All right, look at the next one. Obviously, we can't get to the same base here. This one's a little bit different, though, because we have a couple of issues. Now, before we just had one exponential, but now we have two exponentials with two different bases on them. So this one's going to be a little more involved, and you're going to have to kind of go through this. Every year, this is one of those questions that's kind of a sticking point. But understand there's multiple ways to do this. You just have to make a decision how you want to do this. Now, one way to do this would be to take the log base 7, and that would eliminate the one on the left. But you'd still have the one on the right because log base 7 of 3 is still something you have to deal with. Most of the time when you're dealing with a problem like this, it's just a good idea to just use a natural log. And as long as you're doing the same thing to both sides, it really doesn't matter. So what I mean by that, we're going to take the natural log of 7 to the 2x plus 1 is equal to the natural log of 3 to the 2x. Now, what is our next step here? Well, our next step is to get our exponent out from the exponent. And one of the rules that we talked about yesterday was when you have a situation like this, then whatever the exponent is can be moved to the front of the equation. So, or the front of the term. So we are going to have 2x plus 1 times ln of 7. And over here we're going to have 2x times ln of 3. Now we've gotten rid of our exponent. Now we need to simplify this down by getting our variables to one side. But I can't just simply divide out or subtract right now. I've got to distribute and get our terms somewhat similar. So here we would distribute this side. It's going to say 2x ln of 7 plus ln of 7 is equal to, this one is just 2x ln of 3. So now we have x terms. Keep in mind, I know we're saying ln of 7, ln of 3, but ln of 7 is just simply a number. So even though it's saying all this stuff, it's still just 2 times ln of 7. That's some number, x. So I want to move this term over here on the right over to the left because they both have x in them. And then I want to move the ln 7 to the right because it's just a number that I'm trying to get my x's to one side and the just numbers to the other. So this is going to say 2x ln of 7 minus 2x ln of 3 is equal to negative ln of 7. I moved a couple of terms. I moved this one to the right, and I moved this one to the left. Okay, that's all we did. Now, once I get to here, I need to get x by itself. So hopefully we see that we can take x out of both of these, and you end up with 2 ln of 7 minus 2 ln of 3 is equal to negative ln of 7. Hopefully everybody sees that. Now, I've got my x by itself right here. So now all I need to do is divide out what's next to the x. This is going to say x is equal to. This one's going to say negative ln of 7, and we are dividing by 2 ln of 7 minus 2 ln of 3. Plugging all this in your calculator, we would then get an answer. So let's take a look at our calculator, make sure we understand how we can use this. You're going to need that set of parentheses at the bottom. This is going to say negative ln of 7, close your parenthesis, divided by, open a parenthesis. Then it's going to say 2 ln of 7, close that parenthesis, minus 2 ln of 3, close both parentheses, hit our button. We're going to get an answer that says it is approximately negative 1.1483. This would be our answer to this one. Now, I know it's a lot of work. I know there's a lot going on there. It's just algebra. That's really all this is. It's just being able to move values around in a function. Here's what I'm going to do. I'm going to pause the video, and I want you to work on this next one. So work through it, and then I will put the answer up. Pause the video. Try it yourself. Okay, we're back. Here's the answer. Hopefully we came close to this and did our math correctly. Keep in mind, if you were going to plug all of this in at once into your calculator, you would need parentheses around the top as well as around the bottom. Or you could just do the top, and then whatever that answer is, you say divide by and then do the bottom. But make sure that you do that accordingly because it is important. Keep in mind, this was the same process. Take the natural log of both sides, move your exponents to the front, distribute, then move your x terms to one side, your number terms to the other, and then factor out your x, divide both sides, get your answer. How about the next one? So the next one looks a little bit different. It's e to the 2x minus 2e to the x minus 3. How would we go about solving a problem that looks something like this? Well, looking at it, kind of looks like a quadratic. Hopefully you kind of see that. The only difference really is that it's got the e's as a base number and the exponents have variables in them, but they're still the same idea. This is still an exponential function, but it is in the form of a quadratic. And because it's in the form of a quadratic, we can kind of use the same idea as a quadratic, which means the big X. We need factors of negative 3 that would add up to negative 2, first of all. And that would give us negative 3 and 1. So I would come over here and then I'd say, well, this is a simple. It really is kind of a simple in this case. We would have an e to the x here. We'd have an e to the x here. And then I just got to figure out what goes inside. Well, if I put a negative 3 and a plus 1, is this going to work? If I take e to the x and multiply by e to the x, so over here, e to the x, and I'm multiplying by e to the x, what is the rule for my exponents? Well, the rule for my exponents is that I'm supposed to add them. So this would be e to the 2x. That works. Now I would have a positive 1e to the x and a negative 3e to the x, and when I added those together, I would get exactly negative 2e to the x, and then multiplying the 2 at the end, you're going to get a negative 3. So with that in mind, I get all of this. It's all equal to 0. I'm not done, though, because I do need to solve this out. This is e to the x minus 3 is equal to 0. So e to the x is equal to 3. And then e in this case, sorry, in order to do this, you can either write it by saying it is an exponential, and I'm going to solve it as a log. So taking the natural log of both gives me a log base e. So this is the natural log of 3, which is equal to x. So x would be approximately the natural log of 3, which in this case is 1.0986. So here's one answer. And then looking at the other answer, I would have e to the x plus 1 is equal to 0. So e to the x is equal to negative 1. Then if I were to do the same thing, I would have the natural log of negative 1, which is equal to e, sorry, not e, but x. But then hopefully you realize that this can't happen because you can't take the natural log of a negative number. So at that point, we should hopefully understand that there's only one answer, and it's this one. Hopefully we kind of see that. Last question. I'm going to have you take a look at it, pause, and try it yourself. So same idea as the last question. Pause the video. Okay, here's the answer. I know this one is a little tricky. When you look at it, you kind of want to treat the 2 like it's a coefficient, but the 2 is really the base number. It would be no different if we were just saying it kind of like this, x squared plus x minus 12. It's kind of the same idea. The only difference is the base is a 2 instead. So those numbers that are sitting there, they're not the coefficients. They are simply the base numbers, and you have to treat them as such. So in a problem like that, it's going to be a little bit trickier. Just pay attention to the fact that what part of this is the base and what part of it is the coefficient, and that should hopefully help you solve this. That's it for today's video. Hopefully we get an idea of this. You should be working on your homework, and we will see you next class. Have a great day. Bye.